Good morning, kids. In today's class, we are going to discuss about the magnetic effects, magnetic effects of current. This will magnetic effects of current. 2024 JEE Mains, January shift PYQ. So again, we have the most of the problems are related to motion of charge particle, F equal to BIL, magnetic force, magnetic torque, dipole moment. All the ideas will be below. Then Ampere's circuit law. So we'll explore the problems. We'll get some basic picture. In meanwhile, I'll explain also the various concepts that are involved. Two circular coils P and Q of 100 turns each have same radius pi centimeter. The current in P and R. P and Q are 1 ampere, 2 ampere. P and Q are placed in the planes mutually perpendicular. This is Q. Their centers coincide. The resultant magnetic field at the center of the coil. So I'm having here two coils. This is the one coil. Having same radius. There's other coil, I'll draw it. They will become mutually perpendicular, and I'll draw like this. There's another coil. There's other coil will be like this. So they're having the same radius. Now call this as P and this is Q. Both are having 100 turns, NP and NQ. The magnetic field produced by the coil P will be mutually perpendicular. The net magnetic field at the point 2 should be equal to BP square plus BQ square. This should be equal to whether mu naught Ni by 2R. Number of turns NP, carrying current, call IP, and this will carry a current IQ, IP, and this will carry a current IQ. They're having same radii. Plus this will be mu naught NQ IQ by 2R whole square. So mu naught 2R will come outside. NP IP whole square plus NQ IQ whole square. Here to convert everything, the current number of turns also constant, so we'll make it N. So substitute all that. Mu naught will be 4 pi into 10 to the power of minus 7. 2 radius will be pi centimeter. Pi into 10 to the power of minus 2. Number of turns 100. This will be 1 square plus 2 square. Pi will get cancelled out. Okay, this will be 2. 2 to also get cancelled, pi get cancelled. 10 to the power of minus 5, 10 to the power of minus 3. Okay, this will become centimeter. 4 pi into 10 to the power of minus 7, not value. This will be root 5. Okay, fine. Huh? So we'll end up with this will be 2 into so 2 you send inside. This will become root 20 millitesla. Okay, sir, why you are taking the under root? Because the fields will be perpendicular. The field produced by both the rings at its center will be perpendicular to their plane. So if this is the loop P, it will produce B bar into the plane like this. Then the other loop is like this. So that will produce B bar in this direction. So these two will be perpendicular to each other. So therefore we have to take the vector sum. Fine. Take the next one. Uniform magnified acts along y direction. A rectangular loop of side torque due to dipole moment question is being asked. Acts along positive y direction. A rectangular of side 20 centimeter tangent with current of 5 ampere in yz plane. Okay, I'm having the loop in yz plane. The loop is kept. (20 centimeter) and this is 10 centimeter, and the magnetic field is along y-axis. A current of 5 ampere and a current of 5 ampere with current of 5 ampere is flowing. The current is anti-clockwise with respect negative x-axis. So with respect to negative x-axis, let me draw the basic diagram. This is the positive x-axis, negative x-axis. The current is anti-clockwise, so the current here will flow in this direction, 5 ampere. Okay, fine. So now he's asking to get the torque, the magnitude of direction of the torque. First, we'll calculate the dipole moment. M bar equal to I into A, anti-clockwise. The torque will be along negative x-axis minus I cap. Current is how much? 5. This will be area 10 into 20 centimeter square, 10 to the power of minus 4. Okay, fine. This will be minus I cap. I 2 ja 10, 10, 0.1 dipole moment, ampere meter square, minus I cap to 5 ja 10, 10. Okay, there's a dipole moment. Then, okay, we have the magnetic field acting along positive x-axis. Torque equal to m bar cross b bar. M bar is minus 0.1 I cap. Magnetic field vector is along 2 into 10 to the power of minus 3 j cap. I cross j will be k. 0.2 or along negative z direction. So what is the formula? Torque due to dipole moment. What is the dipole moment? Current into area, and it's a vector quantity. This will be your loop. A little bit, I think we should. The current is in anti-clock with respect to negative x-axis. This sentence very important. इस सेंटेंस से हम ये फाइंड आउट करते हैं कि लाइक इसका नेट टॉर्क कौन से डायरेक्शन में है, तो डाइपोल मोमेंट कौन से डायरेक्शन में है. अगर आपको डाइपोल मोमेंट पता है तो देन ओके डायरेक्टली यहाँ पे फॉर्मूला में लगा दो m बार क्रॉस b बार टॉर्क. About z axis the loop is set to rotate. तो टॉर्क का डायरेक्शन ओके फाइन. दूसरा प्रॉब्लम ले लेंगे. Electron moves through uniform magnetic field. At a particular instant of time, the velocity of electron is. The magnetic force on electron is varies the value of B naught. So the formula we'll be using is F equal to Q V bar cross B bar. What is the value of F? F equal to phi E K, where E is the value of B naught is asking. Electron. So this will be phi E K cap. Charge of electron E. Velocity vector 3 I cap plus phi j cap cross B naught I cap to B naught j cap. We get cancelled. So phi k cap. I cross I will be 0. I cross I 0. I cross j will be k. I cross j will be k. So this will become 3 I cross 6 B naught k cap. Then j cross I cross j k. J cross I will be k minus phi B naught k cap. B naught equal to phi Tesla. K cap will get eliminated. So phi equal to 6 B naught minus 5 B naught. So B naught equal to 5. ये तो सिंपल फॉर्मूला आपको अगर आप याद रहे तो मूविंग चार्ज पार्टिकल फोर्स मैग्नेटिक लॉरेंज फोर्स ऑन पार्टिकल मूविंग इन ए मैग्नेटिक फील्ड. जस्ट ओनली ए फॉर्मूला आपको पता रहे तो यू कैन मैनेज. नेक्स्ट क्वेश्चन ले लेंगे. टू पार्टिकल्स Two particles x and y having equal charges are being accelerated to the same potential difference. Thereafter, they are normally in a region of uniform magnetic field and describe circular path of radius, the mass ratio of x and y. Equal charges accelerated through same potential difference. So basic electrostatics, if a charge particle accelerated to a potential difference, Q1 V, to same potential difference, इसका V naught ले लो. Then this should be equal to m1, the kinetic energy, let it be k1. दूसरा वाला q2 v0 k2. Kinetic energy इसका m1 v1 square by 2, m2 v2 square by 2. If a charge particle moving in a circular path, उसका रेडियस कितना होगा? m1 v1 by q1 by b. इसका मोमेंटम 2m1 k1 by q1 by b. ये तो जनरलाइज फॉर्मूला हुआ. सो r2 का रेडियस ऑफ सेकेंड पार्टिकल का मोमेंटम बाय चार्ज. ओके, इसका वैल्यू हुआ 2m2k2 by q2b. Ratio of radius, the mass of ratio of x and y, m1 by m2. ये तो रेडियस r1 ले लेंगे. ए वाला हुआ x, ए वाला हुआ y. m1 by m2. r1 by r2 whole square equal to 2m1 k1 by q1 by b, 2m2 k2 by q2b. दोनों का चार्ज सेम है. दोनों का चार्ज सेम है और दोनों का काइनेटिक भी सेम है. q1 इक्वल टू q2, k1 इक्वल टू k2. और दोनों सेम मैग्नेटिक फील्ड में घूम रहे हैं. सो देयरफॉर ए वो ए टोटल m1 by m2. So this will become r1 by r2 whole square. A concept electrostatics का है. If a charge particle accelerated to a potential difference, then it will a kinetic, it will acquire kinetic energy, and because of that kinetic energy, it will move in a circular path in a magnetic field. Sir, like what is that magnetic field? यहाँ पे आप what is the magnetic field? Magnetic field इसको यहाँ ले सकते हैं. तो चार्ज पार्टिकल यहाँ पे घूम रहा है. Positive charge particle velocity, b bar velocity, the force. Because of force, it will move in a circular path. Just ये भी Lorentz force का, just a formula of Lorentz force. अगला question. A charge is moving with a velocity along the positive axis under a magnetic field of strength. The force acting on the charge particle based on the Lorentz force F bar equal to q v bar cross b bar. इसका मैग्नीट्यूड ऑफ फोर्स पूछ रहे. क्यू क्यू का वैल्यू कितना? चार्ज 4 माइक्रो कूलम. माइक्रो यहाँ पे रख दो. वेलोसिटी 4 into 10 to the power of 6 j cap cross 2 k cap. j cross I, इसका फोर्स का वैल्यू, we have to calculate the magnitude. j cross k will be I, 4 micro 8 into 10 to the power of 6 I cap. x इक्वल टू माइक्रो, माइक्रो का वैल्यू कितना है? 4 into 10 to the power of -6. ये हुआ 32. सिंपल ना. लॉरेंट फोर्स अगर आपको ये फॉर्मूला पता रहे तो डायरेक्टली सब्स्टिट्यूट कर दो. अगला क्वेश्चन. A current of 5 ampere flows in a square loop of side 1 meter placed in it. The magnetic field at the center of the loop is. कहां पे पूछ रहे हैं? सेंटर ऑफ द लूप. इसका वैल्यू इसका वैल्यू फाइंड आउट करेंगे 1 2 3 4। इसका वैल्यू कितना हुआ? थीटा 45 डिग्रीज। अल्फा, ये हुआ अल्फा, ये बीटा, ये जो लेंथ है L/2, L/2, tan 45। पहले हम इसका लेंथ फाइंड आउट करेंगे D। tan 45 डिग्रीज इज इक्वल टू, और tan अल्फा इज इक्वल टू L/2 by D, tan 45। साइड लूप लेंथ कितना है? 1/2, 2/D, so D is equal to 1/4 मीटर। एल का वैल्यू 1 है ना, 1/2 मीटर। और बिना ये कैलकुलेशन आप ये बोल सकते हैं ना, दिस विल बी हाफ मीटर, ये हाफ मीटर हुआ। सम रेक्टेंगुलर रूप है तो यू हैव टू थिंक लाइक दिस। ओके फाइन। बाद में ओके हमें tan, सो व्हाट इज द फॉर्मूला? मैग्नेटिक फील्ड एट द पॉइंट O, the net magnetic field at point O will be 4 times of B12। जितना फील्ड this particular wire produce कर रहा है, the same field will be produced by this wire and this wire। So the field produced by the wire 1 2, 4 times of that will be the net field। Fine, so this will be mu naught I, let the current flowing I, 4 pi D sin alpha plus sin beta। 4 mu naught का वैल्यू 4 pi into 10 to power of -7, current 5, 4 pi, डिस्टेंस कितना हुआ? हाफ मीटर, 0.5, साइन अल्फा, साइन 45 डिग्रीज, साइन 45 डिग्रीज। 4 कैंसल हो जाता है, 4 इंटू 10 to power of -6 इंटू 5, 1/√2 प्लस 1/√2। √2। यहाँ पे √2 सेम रहेगा, 4 5 जा 20, 2/√2, √2, 2√2, 20√2 into 10 to power of -6। कैलकुलेशन एक बार चेक कर लो। म्यू नॉट वैल्यू तो 4 पाई इंटू 10 टू पावर ऑफ -7, करंट का वैल्यू 5 हुआ, 4 पाई म्यू नॉट 10 टू पावर ऑफ -7 पूछ रहे हैं ना। डी का वैल्यू तो 0.5 है, सो 20√2 इंटू 10 टू पावर ऑफ -6, 10 टू पावर ऑफ -7 बोले तो 200√2 हो जाएगा ये। 200√2 इंटू 10 टू पावर ऑफ -7। आंसर दिया है 40 है। इसका तो हम करेक्शन ले लेंगे, दिस विल बिकम 200 है। सो आपको मैग्नीफाइड ड्यू टू फाइनाइट रॉड, ये याद रहना चाहिए। सो व्हाट इज अल्फा? अल्फा, ए वाला अल्फा 45 डिग्रीज, ये भी 45 डिग्रीज हो जाएगा। देन 4 पाई डी म्यू नॉट आई 4 पाई डी साइन अल्फा प्लस साइन बीटा, वाई 4, बिकॉज चारों वायर के लिए एक वायर इतना फील्ड प्रोड्यूस करता है, चारों वायर 4 टाइम्स। We'll take the next question. A rigid wire consists of a semicircular portion and two stations. The wire is partially perpendicular magnetic B equal B naught as shown in figure. The magnetic force on the wire if it as a current I. यहाँ पे ऑप्शंस मेरे पास नहीं है। A was semicircular wire. A वाला semicircular wire, A वाला long semi infinite wire है। यहाँ पे हमें फील्ड फाइंड आउट करना है। We'll give numbering due to this will be 1, 2, 3. So the net field at point will be O, B1 bar, B2 bar, B3 bar. B1 bar will be mu naught I 4 pi R. The magnetic field will be यहाँ पे into the plane है, minus K cap. ये वाला तो K cap. Then B2 का भी mu naught I. The magnetic force on the wire. पहले हम is asking not magnetic field. मैग्नेटिक फोर्स पूछ रहे हैं, तो F1 बार कैलकुलेट करेंगे। F1 bar will be equal to current, यहाँ पे I, इसका कैपिटल I बना देंगे I, ये दोनों का तो फोर्स F1 एंड F2 विल बी इक्वल एंड अपोजिट। के दोनों सेमी इनफाइनाइट है, force will be 0. Only on F3 it will be non-zero. Then effective length will go for it. Current I B naught pi R. करंट यहाँ पे इस तरफ फ्लो हो रहा है, तो B bar current will be along negative this one. Let me use the vector form. I bar L bar cross B bar, F equal to BL formula. A was current I, length will be effective length will be 2R I cap. B का वैल्यू कितना है? B naught K cap. तो I cross K cross I will be J, I cross K minus J, so minus 2BI to B naught IR J cap. And F1 F2 will be 0. F1 bar F2. So therefore AU होगा net force. What is the net force? Actually net force will be F1 bar plus F2 bar plus F3 bar. AU was 0. So minus 2B naught IR J cap. Capital I we are replacing with small I, so that you should not get confused with the unit vector I cap. The ampere force का formula है, you have to remember this formula. F इक्वल टू बी आई एल फॉर्मूला। अगला क्वेश्चन ले लेंगे। ये तो थोड़ा मोशन ईएमएफ का फॉर्मूला है। E इक्वल टू एस dB by dt. EMF induced when the field is changed to 3000 Tesla in 2 seconds, and EMF induced produced in the coil. If the diameter of the coil is diameter of the coil पूछ रहे हैं, so area will be pi d by 2 whole square. Magnetic field कितना change हो रहा है? 2 seconds. पहले कितना था? 5000. अब A बन चुका 3000. कितने टाइम में? 2 seconds. इसका वैल्यू सब्स्टिट्यूट करो. Then the number of turns. N be the number of turns. EMF कितना इंड्यूस हुआ? 22 n pi diameter 0.02 by 2 whole square a 2000 by 2 22 n pi 1000 approximate in values number of turns पूछ रहे हैं. 22 n pi का वैल्यू कितना? 22 by 7 into 10. 10 to power of -1. So n equal to 70. ये तो हुआ Faraday's law. In Faraday's law, EMF produced due to change in magnetic field. अगला क्वेश्चन ले लेंगे. ऑलरेडी कर चुके ना. दूसरा वाला ले लेंगे. A regular polygon of 6 sides is formed by bending a wire of length 4 pi meter. Perimeter polygon का लेंथ कितना? 4 pi meter. यहाँ पे इलेक्ट्रिक करंट फ्लो है 4 pi root 3 एम्पियर flowing through sides of the main field at the center of the polygon. यहाँ पे कितना magnetic field? At point of we have to calculate. इसका length polygon 6 sides. Regular polygon of 6 sides. तो इसका जो length L A हुआ L by 2 30 degrees. ये वाला भी 30 degrees. So we'll calculate due to 1 2. जितना फील्ड 1 2 प्रोड्यूस करता है उतना ही फील्ड 2 3 3 4 4 5 5 6 6 1. तो पहले हम फील्ड प्रोड्यूस बाय द साइड 1 2 विल कैलकुलेट. देन विल ऐड अप ड्यू टू ऑल. दैट विल बी द नेट फील्ड. उसके लिए हमें फॉर्मूला लगे. दिस विल बी द डिस्टेंस d. This will be the distance d, that one. For this, we'll use the formula cos 30 degree equal to d by L. What is this 4 pi meter? 4 pi meter तो A हुआ L no. So 4 pi should become equal to 6L. L का वैल्यू कितना हुआ? 2 pi by 3. Cos 30 का वैल्यू root 3 by 2 d. L का वैल्यू 2 pi by 3. So d का वैल्यू कितना हुआ? 3 root 3 pi. Then यहाँ पे magnetic field due to 1 2 will calculate. कहाँ पे? At point 1, at point 2. तो इसका वैल्यू mu naught I mu naught I 4 pi d sin 30 degree sin 30 degree. Mu naught का वैल्यू 4 pi into 10 to power of -7. करंट का वैल्यू 4 pi root 3. 4 pi. D का वैल्यू 3√3 pi. Sin 30 1/2, 1/2. इसमें से ज्यादा सा ये 4 pi will get cancelled. pi√3 10 to the power of -7, 4 4. ये वाला 4 pi cancels. यहाँ पे pi√3 4/3 into 10 to the power of -7. ये जो फील्ड है ड्यू टू वन वायर, ये अकेला this side 1 2 will produce field at the center this much. No, कुल मिला के due to complete hexagon, how much it will be? 6 times of B12. 6 into 4/3 into 10 to the power of -7. 8 into 10 to the power of -7. करंट का वैल्यू करेक्ट ले चुके हैं ना, म्यू नॉट 4 पाई डी का वैल्यू. डी का वैल्यू पे कैलकुलेशंस विल बी 1/√3. 2 pi to 2 pi pi pi/√3. डी का वैल्यू pi/√3. pi गेट कैंसल्स, ये पाई कैंसल्स हो जाएगा. तो 3 4 जा 12, ये होगा 12. So 12 into 6 72. ओके फाइन. यहाँ पे थोड़ा गलत हुआ था. तो दिस विल बी योर आंसर. तो आपको ये फॉर्मूला याद रहना चाहिए. मैग्नेटिक प्रोड्यूस्ड बाय द फाइनाइट वायर. व्हाट इज द जनरलाइज्ड फॉर्मूला? B equal to mu naught I 4 pi D sin alpha plus sin beta. अगर आपको ये पता है, दिस इज द वायर, दिस इज परपेंडिकुलर डिस्टेंस, ये वाला हुआ अल्फा बीटा. ओके फाइन. अगला क्वेश्चन ले लेंगे. वेरी इजी. जस्ट लाइक ओनली फॉर्मूलास अगर याद रहे तो भी यू कैन मैनेज इन एग्जाम. Okay, this is a question based on the so we have to calculate the magnet is the center of wire loop formed by two semicircular wires. There's a wire of radius R2, this R1. We have to calculate the magnet field. So what is the net field at point 2? We'll assume current I flowing in the direction. So this will be mu naught I by 4 R1. Field here into the plane. Then mu naught I 4 R2. This will also be into the plane. So this will be mu naught I 4 1 by R1 plus 1 by R2. Mu naught value will be 1 by R1. This will be 2 pi. This will be 4 pi. Okay, the I value will be 4 pi. mu naught will be 4 pi into 10 to the power of minus 7. Current will be 4. So we'll solve it. We'll get the B naught as 3 Tesla. Will be 3 into 10 to the power of minus 7 Tesla. Okay, fine. Simple. You should remember the formula. Due to semicircle, mu naught I by 4R. Due to circular wire, it will be mu naught I by 2R. Next one. The magnitude of main field at point P midway between the wires. Too long. So due to this, wire 1, let me draw the this is exactly the midpoint. We have to calculate the magnetic field. So due to this current I, here current will be in this direction. So what is the net field here due to wire 1, wire 2? The net field at point P will be B1, will add up. Due to this, will add up. This will be mu naught I 2 pi x. Mu naught I 2 pi x. Due to both the wires, you have to add up. Due to 1 into the plane, due to 2 also will be into the plane. So this will become mu naught I pi x. Mu naught value 4 pi into 10 to the power of minus 7. Current 10 pi x value will be the separation 2.5 or 5 by 2. 5 by 2 into 10 to the power of minus 2. Solve this, we'll get the, in terms of micros Tesla, this will be 160 into 10 to the power of minus 6 Tesla, will get it. Magnetic field due to long wire formula should be used here. Then, if a proton moving at a constant velocity passing through without changing velocity, if E bar and B bar are present, what is the net force on it should be equal to Q V bar cross V bar Q E bar. For first, like F to be 0, what are the conditions? If E0, B0, okay. Next, for F to be 0, if E equal to 0 and V bar perpendicular to V bar parallel to B bar and B bar not equal 0, possible. And next, F will be 0 when Q V bar cross B bar equal to minus Q E bar. For this case, B not equal 0, E will be not equal to 0. So we'll pick up these options. Okay, this one. A galvanometer, a moving coil galvanometer having 100 turns, area, magnetic field produced by B, the deflection and current of pass space. The torsional constant is asking. What is the basic formula for this? Torsional constant equal to NIAB. Then there should be some K deflection pi NIAB. K के value पूछ रहे हैं. So number of turns 100. Current 10 into 10 to the power of minus 3. Area 2 into 10 to the power of minus 4. Magnetic field 0.01 by this will be 0.05. We'll get the torsional constant. ऑलरेडी कर चुके. Okay, these are the like a January shift on magnetic effects of current. So what are the basic formulas? Biot-Savart law. Then magnetic dipole moment F equal to Q V bar cross B bar. Then galvanometer torque equal to NIAB. अगर तुमको ए फॉर्मूलास याद रहे तो एंड F इक्वल टू बी आई एल. जस्ट फॉर्मूलास. अगर तुमको ये फॉर्मूलास याद है एंड बाकी थोड़ा बहुत इंग्लिश, start reading, analyzing. So what is unknown thing, what is the given things, search it and you can manage this topic very easily. Just it takes half an hour. Just F equal to BIL condition, F equal to QVB, magnetic dipole moment, Biot-Savart law, Ampere circuit law, galvanometer. Read theory 1 hour, revise it, remember formulas, then start working. You can really do things very easily. यहाँ पे इतना दिक्कत भी नहीं होगा. ओके, दिस इज जनवरी शिफ्ट. ओके, नेक्स्ट वीडियो में हम अप्रैल शिफ्ट का अपलोड करेंगे. ओके, थैंक यू वेरी मच.